Hi. Imagine for a moment that you're a violin maker, Antonio Stradivari, or if you like, Giuseppe Guarneri. You're a craftsman with an immense knowledge of your art and years upon years of experience. What would happen if all the tradesmen you knew suddenly disappeared? The timber merchant you buy your wood from, gone. The wire maker from whom you purchase wire to make your strings, and the man down the road who sells varnish. All of them, no more. In a flash of horror, I think, you would suddenly realize the immense chain of resources and trades that you depend upon for your livelihood as a luthier. Let's pick just a single component of your violins. The sides of the violin, or the ribs as they're known in the trade. These are usually made by heat-bending strips of hardwood, typically maple. But before the small blocks of maple get to you, they've been attended to by the skills of an entire industry. A sawyer at a lumber yard who turns trees into planks and blocks. A lumberjack who felled the tree. But a lumberjack uses an axe, which requires an axe maker or a blacksmith to forge the head on that axe. And every single one of these, I've only picked one piece of your violin, and I've listed half a dozen highly skilled trades that require years of training and practice. No one person could ever hope to succeed in all of them simultaneously. Even if you somehow managed it, how much time would you have left to spend on what really mattered? The sound of your violins. After all, as a violin maker, you exist to serve violinists, and through them, the audience. Enough about violins, for now. What about a field you probably know more about? How many of you have ever written any JavaScript? My sympathies. I have, but anyway. So, if you know JavaScript, you probably know something about the DOM programming model, which is an abstraction in a browser, which runs on an operating system, which has a runtime API. And your operating system has at its core a kernel, which is probably written in a programming language called C, which I'm sure you all know, which is compiled by a very large and complicated program, a compiler, probably GCC. And the compiler knows all about the machine code that runs on the particular processor that's in your computer. And that machine code triggers the action of thousands, if not tens of thousands of circuits in that processor. And those circuits are made up of hundreds of thousands or millions of transistors. And if you want to understand how a transistor works, you need to understand semiconductor physics. And if you need to understand semiconductor physics, then you need a not inconsiderable grasp of quantum mechanics. So, I asked how many of you have ever written any JavaScript. How many of you would say that you are au fait with quantum mechanics? Yeah, there's always a few. I'm just going to quote Richard Feynman, one of the greatest quantum physicists of, well, I mean, I say of our generation. He's not, he's dead. But quantum physics has only been around since about 1920s-ish. I think I can safely say, he said, quoting verbatim, that nobody understands quantum mechanics, so you're all liars. Also, I did a physics degree, and I've got no idea. But that's incredible, isn't it? Only a few of you even claim to have knowledge of a technology without which JavaScript could not exist. JavaScript is fundamentally dependent on the chain that leads all the way down to quantum mechanics. Without an understanding of quantum mechanics, there would be no transistors. Without transistors, you get the point. So how do we ever get anything done? I'm sure it's obvious to everyone that you don't need to understand quantum mechanics in order to write JavaScript. For one, there would be much fewer JavaScript programmers in the world, which might not be a bad thing, but anyway. It's obvious that you don't need to understand quantum mechanics to be a good JavaScript programmer. But I don't think that it's obvious why that's true. Why don't you? It's fundamentally dependent on quantum mechanics. And I propose that the answer is what physicists call black box abstraction. And I'm sure you've heard this referred to in many different ways. But black box abstraction is fundamentally the process of wrapping complex or complicated things up into a box that has pipes, Unix pipes, pipes to get stuff into it, and pipes to get stuff out of it, but which hides the full complexity of its internal machinery. Our violin maker doesn't know how to fell a tree. He doesn't know how to make an axe. But he has commercial relationships with people who do. And none of the complexity of forestry or axe making leaks into those commercial relationships. So he doesn't have to worry about that stuff. And he can concentrate on what he's good at. And you, writing your JavaScript, you don't need to understand quantum mechanics, because black box abstraction is everywhere in the technological world. The DOM is a black box abstraction. Functions are an abstraction. Object-oriented programming is or enables abstractions. Assembly language, infrastructure as a service, every single API ever written is an abstraction. Except SOAP, which is the only known abstraction that's more complicated than the system it represents. Black box abstractions, I posit, are the central paradigm for technological advance. And this is the critical point. They allow you to reason about systems of unreasonable complexity. As soon as a technology or process can be packaged up in a black box through which it exposes some small but useful fraction of its inner complexity, its users can concentrate on using it rather than trying to understand how it was made. Picking the right abstractions, though, or designing interfaces, or APIs, or whatever you call them, is hard. We all know this. There is no rule book. There are no algorithms to help you decide what the right abstraction for your particular problem is. But we at GDS, even if we're not such philosophical idiots as I am, believe that doing that right requires one thing above all others, that you understand the people who will be using what you make. And here's the critical point. I work in operations. I mainly do not build tools for what we would usually call end users. I build tools for other programmers, or at least I would like to build tools for other programmers that they use and become a part of their job. But they're my users, right? So why do we make a distinction between users and makers? Even if the people who are your users are other makers, and in most cases they are, even when you don't think they are, you need to make sure that you're writing tools for them, and that you understand their needs, and that you understand how much complexity you should expose. If you don't get what I'm saying yet, if I'm not being clear, your users are all that matters. Serving users, however, is a difficult problem. But we're being impolite. We haven't introduced ourselves. Hi, I'm Nick, and this is Mazz. And Mazz is now going to talk to you about something else.
Ooh, mystical. Hello. Yeah, Nick got a bit carried away and jumped straight into the talk, but that's all good. We work at GDS, that's the Government Digital Service. Some of you might be familiar with the website we worked on, gov.uk. It's the front door to British Government Information and Services with jazz hands. Gov.uk, don't quote me on that, please. Gov.uk started out as an idea, an alpha. The idea was to test in public a prototype of a new single UK government website, which was to be shaped by an obsession with meeting user needs. So according to my notes, 2011, in just 12 weeks, a cross-disciplinary team of only a dozen people successfully built the alpha from scratch. There wasn't much rejoicing. I wasn't there, so I couldn't do some jazz hands, but I'm sure there was. And then shit started to get serious. The idea was approved to build the next stage, which was a beta. The beta was done over the course of about 8 months, again worked on by a cross-disciplinary team of approximately 43. They also did some rejoicing. I also still wasn't there. Then shit got really real. The go-ahead was given for the beta to be turned into the single UK government website. Started in February 2012. I did eventually get to join, thanks to you. And we got launched. We were launched in October of 2012. Again, it was worked on by a cross-disciplinary group of teams of approximately 200-something people. Wow. So how did we go from a team of 12 during the alpha and scale it up to over 200 in a very short amount of time? Well, we certainly didn't hire any of these. That's a mini Ozzy Osbourne but a rock star. Nor any of these, singing titles of ninjas or wizards. There seems to me to be a common misconception in tech that all you need if you need to deliver faster, better, stronger code is Rockstar. Sorry, this is a lie. No one person can carry the success of your product, your team, or your company. To think like that, to use a concept some of you might be a little more familiar with, you're introducing a single point of failure. Sure, having a rock star in a team might solve some short-term problems, but ultimately you will have a disaster, a faster, worse, or a fuck-up. And to be honest, I'm pretty tired of seeing the same description of what makes great rock star developers. It's like carbon clones of each other. You've all got to live and breathe code and drink from the same ego-boosting Kool-Aid, shouting the same opinions over each other, ranting about the right way to do something. And then in my 10-year experience of being a developer, inevitably making the same mistakes, because they all have the same kind of blind spots. So I'm saying needing rock stars is bullshit. Not just my opinion, but for all of you, think about what this is doing to your team if you have that one or unfortunately two rock stars. What happens if, let's say, the rock star gets eaten by a T-Rex? See, we know that rock stars don't work well with others. Rock stars on a web scale. Generally the ones I've come across believe that their egos are far more important than listening to what their users need. And as Nick was mentioning, when I say users, I mean the people in their teams and the other teams of teams recursive. And by not listening to any of those, it actually leaves your team with very little collective intelligence. Because if you can't work well with others within your own discipline, you're certainly not going to work well with others from different disciplines, which then means you can't see those black box instructions. And if you can't see them, you can't interact with them well either. But it's okay, don't worry, it's all cool. There is another way. No, sorry, not T-Rex playing a guitar, but I couldn't resist. The answer is cross-disciplinary teams all working together. And for me, I'm proud to be able to say that there is not a single rock star working at GDS, and we have approximately 20-something developers, so over 200 people. But this was no accident, so how did we do it? Well, good team needs diverse good people. What do I mean by that? Recognising how important it is to assemble a good, passionate team and then doing so is a skill in its own right. And throughout the creation of GDS, it wasn't about hiring just the very best technical minds. It was about hiring a diverse group of people who were best able to understand what gov.uk was trying to achieve. Because building things is hard, you've got to understand who you're building for and what they want to see. And if you want others to then use your work, you've got to understand how much of the complexity of that problem, whether you're writing code or helping to explain government policies, you've got to figure out how much of that complexity needs to bleed out to other people so they can then understand it. So yeah, it's a bit hard. So, as with any problems that are hard, fuzzy, ill-defined and quite difficult, the best thing you can do is to give it to people. Lots of people. Lots of really good people. Hire people that get that, and then you can trust them to go forth and build for their users. So yeah, sorry I'm not giving a silver bullet or a single secret to success, but there's also the what works for one problem doesn't work so well for another. Very quick example, the tools and processes that were used during the alpha, given that it was a small team of 12 who were sat next to each other, talking to each other all day, every day, and given the timescale, the content at the time was hard-coded. That was good enough. Brilliant. During the beta, that was no longer good enough, so a small group of developers was sat with at least one content designer, and they put together a really lightweight version of a tool known as Publisher. That helped us get the beta. Brilliant. When it was for real, and as been mentioned, we scaled so much, suddenly you've got all these other people and other teams and other stuff, and that's really hard to scale that process up. We had to continually iterate, not just our processes, our people, but also our tools, because you've got to meet the demand of an ever-expanding team. And I can say, we didn't always have the know-how, but that didn't stop us, because we had the right group of people. We're all intelligent, most of us are fun, but above all, seriously, above all, everybody is respectful. We worked together. We figured stuff out together as best we could. And then once we built it, we iterated over it and made it better again. So, on paper and in reflection, going from alpha to beta to live in such a short time frame shouldn't have worked. It's all kinds of crazy and chaotic, and it seemed impossible. It was only possible because, as a team, collectively, across all the disciplines, we never lost sight of the most important thing.
Can you see what it is yet? What's the most important thing? Your users. The GDS design principles say they'll start with needs. If you don't start with needs, you're going to build the wrong thing. I like the way that Ken writes, the developer Heroku puts it as well. The user API is all that matters. Everything else is secondary. And if there are two messages you can take away from this talk, the first is that the user is the most important thing you can worry about. And the second is that users aren't just users. Users are your colleagues and makers. And how do you solve these hard-to-do kinds of problems?
Yeah, so Uncle Ben and I realised I put Spikey, that actually makes Stanley. That shirt is going to absolutely fucking kill me. They didn't exactly say this, but I iterated over the phrase because I really like it. I'm sure if they worked with us that they would say that, or something to that effect, or I get locked in a cupboard. Basically what they say is that a diverse, well-fitted, functioning team will make the most of collective intelligence, because they know that the user doesn't care about your ego. You need to leave that at the door to truly get shit done. And for anyone who doesn't believe me or tends to get into arguments with me, usually in the pub, so I look forward to some of those later, gov.uk is a testament to that philosophy. We could not have done that if we didn't leave our egos at the door.
Thank you very much.